how does this connect to n choose k? Well, there's one subset with no elements, right? Okay. So that's, of n objects, how many ways are there of picking no elements at all? That would be n choose 0, right? So n choose 0 ought to be 1, because there's only one subset of size 0 taken from n things, namely the empty set. Oh, is that true? Well, n factorial, k factorial, what's 0 factorial? 1 by definition. That's a definition. And n minus 0 factorial is n factorial. So we have n factorial over 1 times n factorial, which is 1. Right? So this works out to give us the number of subsets of size 0 that there are. Correctly gives them. Well, how many subsets are there of size 1? Well, I could take the first element or the second element or the third element or et cetera on up to the nth element. So there should be n possible subsets of size 1. Right? Please say yes. OK, so what happens if we plug in, look at n choose 1? What do we get? Well, n factorial over 1 factorial. 1 factorial is 1. N minus 1 factorial. What happens when you take n factorial divided by n minus 1 factorial? N factorial is n times n minus 1, n minus 2, n minus 3, et cetera. N minus 1 factorial is n minus 1, n minus 2, n minus 3, et cetera. So all the terms cancel except the first term, which is n. Right? So that cancels that, et cetera, and it just leaves n. Yes? OK, so this agrees with the notion that there are exactly n subsets of size 1 taken from this. You can pick the first, the second, the third.